Reformatsky reaction is an synthesis of a beta hydroxy ester. Synthesis of beta hydroxy ester from carbonyl compounds like either aldehydes or ketones and alpha haloester in the presence of metal zinc is a Reformatsky reaction. Simply, it is a synthesis of beta hydroxy ester from alpha haloester and that is aldehydes or ketones in the presence of zinc in solvent ether. Okay, on hydrolysis we will get this product beta hydroxy ester. Now we will see directly the example. Any aldehydes or ketones, generally that is RCHO is an aldehyde which is treated with alpha haloester, that is a CH2 here, halogen as a Br, C double bond O, OC2H5, that is alpha bromoethyl acetate. In the presence of zinc, here the solvent is an ether, diethyl ether. Here on hydrolysis we will get the product as beta hydroxy ester, that is RCHOH. This carbonyl group is converted into hydroxy group CH2 C double bond O, OC2H5. This is your principal function group. Next to the principal function group, that carbon is known as alpha and then beta. Hence, it is a beta hydroxy ester, is a product of a Reformatsky reaction. Now, see here, in absence of zinc, either the reaction is possible in between these two? No. Since both the carbonyl carbon and this carbon both are electrophilic. Here this carbon is electrophilic due to presence of electronegative oxygen, and here this carbon is now electrophilic due to presence of electron withdrawing group as a halogen. That's why the carbon-carbon bond is not possible. Hence there is a need of the zinc. Okay, here it is a zinc which due to which the reaction is possible. Okay. Now you can take here the particular example as acetaldehyde CH3CHO plus CH2 Br C double bond O, OC2H5 in presence of zinc. It is a reflux in presence of zinc, that is diethyl ether as a solvent. On hydrolysis we will get the beta hydroxy. Now this carbon, there will be bond formation between this carbon and this carbon. Okay, we get a product as here this is CH3 CHOH, this is a CH2 C double bond O, OC2H5. This is again the beta hydroxy ester. Okay, OH group is present on the beta carbon, that is beta hydroxy ester. Acetaldehyde, ethanol, common name is acetaldehyde. Here it is an alpha halo ester and the product is a beta hydroxy ester. You can give the IUPAC name also here. This is your longest chain 1, 2, 3, 4. Okay. Simply in absence of this OH, this is an ethyl butanoate. Now your substance is present on the third carbon, and hence it is an ethyl 3-hydroxy butanoate is an IUPAC name. Again, this reaction is possible with aldehydes as well as ketones as well as cyclic ketones. If you take one of the example of cyclic ketones, for example cyclohexanone C double bond O, in the presence of alpha haloester C double bond O OC2H5. In case of here alpha halo, you can take iodo group as well as a chloro. Here, in the presence of the same, that is zinc, in presence of here zinc and solvent as ether, on hydrolysis we will get the product as here the reaction will be takes place on the carbonyl carbon. The CH2 will be attack on the carbon where the carbon group is present. OH, this is CH2 C double bond O OC2H5. Simply this is your functional group. This is your functional group. This is the alpha carbon and this is the beta. On the beta carbon there is hydroxy group. It means in this reaction, you take any example, you get that is a beta hydroxy ester. Beta hydroxy ester. And further on dehydration in presence of acidic medium, it gives rise to alpha beta unsaturated ester. Since the OH group and the neighboring carbon containing one of the proton, it can be undergo the dehydration in presence of acidic medium and you will get the alpha beta unsaturated ester. Okay, in this way we will get the beta hydroxy ester. Now we will see the mechanism of this reaction. In mechanism part, we having the zinc. Initially, that alpha halo ester will be react with the zinc plus here CH2 Br C double bond O OC2H5. Now, what happens here, that zinc will be react with this compound. That is actually insertion of that zinc takes place in between the carbon and halogen. It is exactly similar to the Grignard reagent. In Grignard reagent, we are taking the RX. Suppose R is this group and X is halogen, and that is treated with metal magnesium. In that case, what happens? The metal magnesium is inserted in between that RX group. Similarly, here the zinc will be reacted with this carbon halogen bond, and here we will get Br Zn CH2 C double bond O OC2H5. That is formation of organometallic compound. The bond is present between metal and carbon directly. It is an organometallic compound. Now here actually zinc having here positive and carbon is negative. Okay. Now you can show the resonance structure of this one. Since this negative carbon and this double bond are in conjugation, that's why we will show the here resonance form. The negative is converted here double bond and here double bond is converted into the negative charge. Here we will get CH2 double bond C. Here this is O minus OC2H5. Now actually that ZnBr will be form here ZnBr, Zn plus Br here. Okay. Here this is an resonance. Now once in this ion is known as enolate ion. As we know that carbon-carbon double bond and the carbon with O minus ion, enolate ion, which is generated in that aldol condensation reaction. Okay. Now once the enolate ion is generated, that will be treated with any one of the carbonyl group which is taken here as here acetaldehyde CH3CHO. Okay. Now this CH2 double bond C, here this is O minus ZnBr here plus charge. On oxygen there is a negative charge. Okay. OC2H5. I will clear the first step of the mechanism here. Now here what happens? This negative charge now form the double bond, and the double bond from that carbon will be attack on the carbonyl carbon. There is a formation of carbon-carbon bond takes place. That is this carbon. What is the role of here zinc? See here that zinc converts that positive carbon into the negative carbon. That means it is now nucleophilic. That carbon will be attack on the carbonyl carbon. Pi electron shifted towards oxygen. It becomes CH3CO minus H. Now this is a CH2. Now this is C double bond O. Now once that negative charge is converted into double bond, that zinc leaves from this position and that will be shifted on this O minus. Here O Zn plus Br, and here this is OC2H5. And the last step is that it undergoes hydrolysis. Finally, this on hydrolysis will get here, break this bond H plus and here the OH minus, will get the product as beta hydroxy ester, CH OH CH2 C double bond O OC2H5. This is an beta hydroxy ester. This is our target molecule. In this way, we will get the beta hydroxy ester. Now, question is that why either it is more reactive than Grignard reagent or less reactive. On the basis of that, the question will be asked either that alpha allo ester it undergoes self condensation type of reaction or not. Okay, there is a ester function group. Okay, that CH2 minus, it may be directly react with itself same molecule and gives rise to product or not, but actually it doesn't react with the ester function group. The reason is that compared to the Grignard reagent, this reagent, that is a organozinc reagent, this reagent is less reactive. That's why it will be attack on the carbonyl carbon and there is no such type of product takes place. Okay, like aldol, it gives rise to the beta hydroxy ester due to only reactivity. Today we will stop here.